Welcome back to the Apex Retail Site Investigation series. In the previous episode, we confirmed that an attacker successfully executed privileged Linux command using Alice Wilson account. At this point, we know that attacker had evaluated privilege, but we didn't know what they intended to do next. Experienced attacker rarely stop after gaining privileged access. Their next objective is usually persistence. Persistence allows an attacker to maintain access even if the original compromise is discovered. It's like a zero-day attack. In today's investigation, we'll examine one of the most common Linux persistence techniques, unauthorized SSH key installation. We'll investigate the telemetry control by Splunk, reconstruct what happened, determine whether persistence has been established, and discuss how such analysis should respond. Before we generate any suspicious activity, however, we need to prepare our laboratory environment properly. We going to create a dedicated user, configure SSH key authentication, generate an attacker key pair from Kali Linux, configure Linux auditing, and make sure Splunk can see the resulting activity. Everything we're doing is inside our control lab environment. We have a Kali Linux, which we are inside the Kali Linux. This is the attacker machine. We have an Ubuntu server. This is Ubuntu server, guys. And we have a Splunk Forwarder, which also this is Ubuntu machine, and a Splunk Enterprise Semi, which is the Kali machine. This is a whole topology. First of all, I'm gonna start with Kali with the Ubuntu and show host name. This is the admin. We have a virtual platform and use who I am, which is admin, and we found our private IP and I wanna starting Ubuntu server because this is the system we're going to monitor. First, I'm checking the host name, and then I checked the network configuration. Then I always recommend doing this before a lab because it prevents us from accidentally configure the wrong machine. We wanna looking for Alice. We have Alice user, or if we don't have Alice user, we can easily add it with this command, guys. If I enter this command, we create Alice user. So I did it before. Then we can verify with this command. For example, id admin. We have a two user ID Alice and admin. Now I wanna create Alice SSH directory. Alice. Then I wanna create a new file which is authorized key, and I use a touch to create that file because the touch command usually check if we don't have this file. It can create it with this name. Now we set ownership sudo chon with the capital R. We wanna to determine who is the owner of this file. Alice is the owner, and home Alice SSH. Yes, it's true. And we set the permission. The Alice how much have permission on this file. SSH from Alice SSH. Then authorized, and now we verify that sudo ls la home. Okay, these are for Alice, and at this point Alice has an SSH configuration directory. The authorized keys, which is our file, is currently empty. That's intentional, and we wanted to establish a clean baseline before simulate the attack. In a production environment, this file could contain one or more legitimate public keys. For our lab, we're starting with an empty file, so that the modification generated later is easy to identify. Now we switched the Kali machine, and let's zoom in. Oh my god. I think that's fine. And make the error -p. We Apex Lab and CD2 Apex Lab pwd, and we wanted to generate the key here. This is the SSH generate key. SSH kgen -TED attacker key. We'll see something like this, and we enter and we generate that. That's perfect. We see attacker key and attacker public key. Actually, this is the private key, this is the public key, obviously. And we now LSLA, we now have our SSH key pair, and in a real environment the private key must remain secret. We should never upload it to the server or share it with anyone. The public key is the part of the public key is the part that get installed into the user authorized keys file. And for today control simulation, I'm using this key pair to represent an attacker persistence machine. Let's cut that attacker up, and you can see long string, and obviously we don't run private key because this is our VM machine, and I don't want to share that because of the security reason that I told you before. And now we want to copy the public key to Ubuntu. We have several ways to do that, and for our lab, let's use SCP. Now, first one, Ubuntu IP address, which I already found out. This is my IP address on that victim system. On the Kali Linux, we start with the CP attacker public IP address admin with the IP. We wanted to send it on the TMP file whole directory actually, and the password. We don't have permission. Please try again. And as you can see, we send it on the Ubuntu file. And if I want to check that, LSL TMP, look at that, perfect. Sudo cats and it's SSH. And as I already talking about that, it actually should return, I think, because it was intentional. Let's check something. Sudo /l, then sudo, and this is our baseline. The authorized key file exists, but it contains no keys, and this gives us a clean starting point. In the next stage, we'll introduce the simulate persistence events, and because Audit is monitoring this file, the modification should generate security telemetry. That telemetry will then be forwarded to Splunk. This allows us to reconstruct the attacker, actually the attack from the defender's perspective. We wanna to install Audit program. Before every installation, we used to do this. Sudo apt update. Now sudo okay, it's already installed, and I think it's active. Yeah, it's our new version. Okay, and sudo nano etc audit rules -d apex rules, which I already had this file. Okay, Control O, Control X, and sudo au gen rules load. We verify sudo auditctl-l. Okay, and we see this command. Now let's talking about that. The W option tells audits which file we want to monitor. Here we are monitoring Alice authorized keys file. The -PWA option tells audit to monitor, write and attribute changes. Finally, -K SSH persistence assign a searchable key to that event. And this key will make our Splunk investigation much easier because we can search especially for events associated with this detection. Now let's test audit before the attack. Actually, we wanted to prove the audits actually detect changing. Sudo au search -k SSH look at that. Just look at that. So we make sure everything works very well. We have a file, we have a logs of the systems, but it's not clear to read easily. But never mind, don't worry about that. We have a powerful program which is a Splunk. Now check the we wanna check configure Splunk Forwarder. Sudo nano Splunk Forwarder etc system already added before. This is the this command audits everything, and if you want to edit this command, actually after you copy paste this command, please save it on the file. Okay, then you should use sudo Splunk Forwarder bin Splunk restart, which we restart our Splunk Forwarder. Okay, now we restart our Splunk. Then we want to check that Splunk Forwarder bin Splunk list monitor, I think monitor our username. Yes. Okay, we have to see var log audit log, var log audit log. Yes, you can see that. That's perfect. We can start a Splunk on our Splunk server. Now let's check. Hello guys. Hello administrator. I'm administrator, guys. If you want to be administrator, subscribe our channel. Okay, index main source type audit. We can find our Linux file. This system is so slow. Stands. Okay, we can see that we have a create Alice Linux account. We create her SSH configuration directory and empty authorized key files. On Linux, we generate EN25519 SSH key pair. This represent our simulate attacker. We transfer only the public key into the Ubuntu server. Most importantly, audit is now monitor Alice authorized key, and Splunk is configured the ingest the result audit telemetry. We now have a clean baseline. In the next part, we're going to perform the actual persistence simulation. We'll add the attacker's public key to the Alice authorized file, and this time we won't just look at the result. We follow the entire event from the moment the file change through audit, through the Splunk Universal Forwarder, and finally into Splunk Enterprise. Okay, this is our colleague, guys. This is our colleague, private and public key, Ubuntu with the SSH key, audit, watch authorized, Splunk Universal Service Forwarder, and Splunk to the Splunk Enterprise. Very well, I hope you enjoy our video and I see you in the next video.